Hi everyone, I'm Tahmid from York University. I'm going to present our paper Query Focused Abstractive Summarization via incorporating query relevance and transfer learning with transformer models. At first, I'm going to introduce you to the Query Focused Abstractive Summarization task. In the Query Focused Abstractive Summarization task, a set of documents along with a query has been given and the objective is to generate abstractive summaries from these documents based on the given query. So what is abstractive summaries? In the abstractive summaries, there may contain novel words which may not be appeared in the source document. An example of query focused abstractive summarization has been shown. We can see that there is a document along with a query given and the summary is generated based on the given query. So what is our motivation for this work? We find that there are several challenges for query-focused abstractive summarization tasks. For example, there are lack of available datasets. Though there are several datasets available for generic abstractive summarization tasks, for the query-focused abstractive summarization, only the Debatepedia or DAG datasets have been used. Moreover, the size of the available datasets is very small. For example, the Debatepedia dataset has only around 10,000 training instances. Thus, the lack of large training data has made it a few-shot learning problem, where training a neural model end-to-end with small training data is a very challenging task. To address these issues, we introduce a transfer learning technique via utilizing the transformer architecture. In our proposed approach, we first pre-train a transformer-based model in a large generic abstractive summarization dataset, followed by fine-tuning the pre-trained model in the target query-focused abstractive summarization dataset. In this paper, we make several contributions. Our proposed approach is the first work for the query-focused abstractive summarization task where transfer learning is utilized with transformer. We also set a new state-of-the-art result in the Debatepedia dataset. Moreover, our proposed approach does not require any in-domain data augmentation for few-shot learning. The source code of our proposed model is also made publicly available. Now we will give a brief review on the recent work related to our paper. We start the related work with a brief review on the generic abstractive summarization task. For generic abstractive summarization, the pointer generator network or the PGN model was proposed, which provided state-of-the-art result in several datasets. The recurrent neural network-based PGN model also overcomes the repetition of same-mode problem, which occurs in abstractive summaries, via proposing the copy and the coverage mechanism. More recently, the BERT-SUM model was proposed. The BERT-SUM model uses BERT as the encoder and the decoder of transformer as the decoder. It also outperforms PGN for abstractive summarization in several datasets. However, both of these models have a common limitation. They cannot incorporate query relevance and thus they are only applicable for generic abstractive summarization tasks. For the query-focused abstractive summarization tasks, the diversity-driven attention model or the DDM model was proposed. It is an encoder-decoder model based on RNN. It also introduced a new dataset for the query-focused abstractive summarization tasks from Debatepedia. However, we find that the DDM model only performs well when the Debatepedia dataset is augmented with more training data. More recently, the relevance-sensitive attention for query-focused summarization or the RSA QFAS model was proposed. This model first pre-trained the PGN model on a generic abstractive summarization dataset and then query relevance is incorporated into the pre-trained model to predict the query-focused summaries in the target datasets. However, this model was not fine-tuned on the query-focused abstractive summarization datasets and also results in a very low precision score by generating very large summaries in the Debatepedia dataset. Now we describe our method for query-focused abstractive summarization task. Our proposed model works in two steps by utilizing transfer learning technique. We first pre-train the BERT-SUM model on a generic abstractive summarization dataset. For pre-training, we chose the XSUM dataset since the generated summaries in these datasets are more extractive in nature compared to the other datasets. Then we can incorporate query relevance in the pre-trained model by concatenating the query with the document and then fine-tune it for the query-focused abstractive summarization task in the target Debatepedia dataset. Here we illustrate how our model works. First, we pre-train our model in a generic summarization dataset. Here an example of a generic abstractive summarization document shown. Then in order to give the document as an input to the encoder of word sum, we separate each sentence with the SAP token and put the CLS token before the start of each sentence. Then for fine-tuning in the target domain, where the query is also given with the document, we concatenate the query with the document to give as input to the encoder. Here we again separate each sentence in the input with the SAP token along with adding CLS before the start of each sentence. In this way, we fine-tune the pre-trained model via utilizing the transfer learning technique. In this section, we discuss the dataset used in this paper. Here we discuss the original Debatepedia dataset which was used in our experiment. The Debatepedia dataset was created from the Debatepedia website. Previous work on this dataset used 10-fold cross-validation. Average number of instances in each fold contain around 10,000 training instances with around 1,300 instances in both the test set and the validation set. It is to be noted that we found in the source code of the DDM model in which Debatepedia dataset was first applied that the dataset was augmented with more training data. In the augmented dataset, the test and validation data were same as the original. However, the training set contains around 95,000 training instances. Now we describe the data augmentation approach of Debatepedia based on the source code of the DDM model, which was not mentioned in the original paper. For data augmentation, we find that for each training instance, 8 new instances were created. At first, a predefined vocabulary of around 24,000 words were created with their synonyms. Then for each training instance, M words in the query and N words in the document were randomly selected, which were replaced by their synonyms found in the predefined vocabulary. If the selected word was not found in the predefined vocabulary, then it was replaced with the most similar word found in the global vocabulary. This process is repeated 8 times to create 8 new training instances. Now we will describe our experiments. For the experiment, we use the original version of the Debatepedia dataset to evaluate our model. For evaluation, we use the ROGI 1, 2, and L scores with their precision, recall, and F1 scores. We also compare our models with several baselines. Here, the QFAS baseline was only trained end-to-end on the Debatepedia dataset without any pre-training. The ABOUT-SUM exam was pre-trained on the XSUM dataset but did not leverage any fine-tuning. Our model was also compared with the current state-of-the-art RSA QFAS with PGN model as well as with the DDA model. Moreover, to investigate the performance of DDA without data augmentation, we experimented with the DDA model on both the original and augmented versions of Debatepedia. Now we will analyze the result of our model. In the following table, the result of different models are shown, where the result of our proposed QFAS model is shown on the last row. In comparison to the baselines, we find that our model outperforms all of them and also sets a new state-of-the-art result. Compared to the prior work, our model outperforms all of them with improvements in all evaluation metrics, most notably a huge improvement in the ROGI2 scores. Now we discuss the findings from our experiment. We find in the original version of the Debatepedia dataset that the transformer-based baselines outperform the RNN-based DDA, which shows the effectiveness of using transformer. We also find that data augmentation significantly improves the performance of DDA. Moreover, our model outperforms both transformer-based baselines, which shows the effectiveness of using both pre-training and fine-tuning. More importantly, we set a new state-of-the-art in the Debatepedia dataset even without leveraging any in-domain data augmentation. In this paper, we address the lack of large datasets available for the query-focused abstractive summarization tasks. We presented a transfer learning technique to elevate the few-shot learning problem and set a new state-of-the-art result in the Debatepedia dataset. In future, we will investigate the performance of our model on more datasets. Finally, we would like to acknowledge NSERC and ORFRE for the funding supports as well as Compute Canada for the computing resources. Feel free to ask us questions if you have any.